This video will go over battery settings using the app. We've logged into our inverter here, and we're going to click on Settings, and then Battery. And now we've got all of our battery settings. When we're using the MidNite batteries, we're going to set our battery brand selection to MidNite. By default, it is set to Pylon, but we want to change that to MidNite when using MidNite batteries. We'll have a separate video going over open loop operation with lead acid battery or lithium batteries with no BMS, where we do voltage settings rather than state of charge settings. Communication address, just leave that at 1. If you're doing different Pylon batteries, you may need to change that, but for the MidNite batteries, just leave it at 1. Capacity type should be state of charge when doing a closed loop system. We have discharge and charge to. This is the point where the inverter shuts off, is like the low voltage disconnect on older systems, and the maximum that we charge it up to. We always want to put the maximum at 100%, and the minimum, we want to leave a little threshold between when the inverter shuts off and when the battery will actually shut off. Because if the battery shuts off, then we have to do a black restart, which can be a lot harder than the inverter just turning back on when the battery recharges. So 15 or 20% for our discharge to is a good number to use. A related one to that is this one, minimum initiation startup battery capacity when off grid. This is essentially when the inverter restarts after it's shut off from low state of charge. So you see we had that one set at 20%, and this means it has to charge back up to 30% before it'll turn the inverter back on. And that's just to give it a little chance to recover before putting the loads back on there. Going back up here, we have our start and stop recovery charging. Recovery charging is only applicable when we're on grid, and it essentially does a little top-off charge of the battery. If it's going dead, the inverter's shut off, but it's still draining the battery just from idle loss. And that uses the grid for a little top-off charge, even if otherwise we wouldn't be using the grid for charging, just to keep it from going into a black start situation. We have also the maximum grid recovery charge power. That's the rate that it does that recovery charge at. Discharge and SOC on grid. This can be thought of as the reserve capacity that we want to keep for off-grid use. So if we're doing mostly net metering with battery backup and we want to keep that battery mostly full for backup, we can set this as high as 95%. We do want to let the battery cycle just a little bit, but they don't have to do very much. But if we're doing some self-consumption, time of use metering, something like that, we could set this much lower. We generally want this to be set higher than where the inverter shuts off, the 20% discharge here. So we're going to set this up at 30%. So when we're on the grid, we can use down to 30% and still leave a little bit for off-grid use. But in some cases, maybe you don't want to use the batteries at all if you're on the grid, and you might set that much higher. Our maximum charge power, if we have a single inverter, 10,000 watts is as much as we can do. Same for maximum discharge power. If it's a single PowerFlow 16, you'll want to set these to 8,000 each, because that's the maximum continuous charge and discharge for a single PowerFlow 16. If you have multiple batteries, then you can set it to 10,000, which is the rating for the inverter. Or you could set it to a lower number for some reason if you want to charge and discharge at a lower rate. Scrolling down, we have charge by grid. This one enables or disables charging the batteries from the grid. can have slightly different functions in some different firmwares, especially when you're doing time-based control. So check out the video on that. This is where we stop charging the battery from the grid. We may say maybe we only want to charge to 80% from the grid and leave a little room for solar to top it off. We do want to make sure we get the battery up to 100% at least about once a week to keep the state of charge calibration for the BMS in sync. So if we're not charging to 100% from the grid, we want to think about, are we getting to 100% every week? Maximum allowed charging power, this is from the grid here. We could set it so we only draw a much smaller amount from the grid, even though up here we allow much higher charging power from solar input, for example. And then force charging, which has the button right here in the corner, that essentially overrides a lot of other controls that may be saying, I've got grid power available, or I've got generator power available, but I'm not in the state of charge range where I'm supposed to be using it, or I'm not in the time frame where I'm supposed to be using it. This will override that and charge it up from any available source, AC generator or AC grid, even if our other programming has told it that we're not going to use that. And that finishes battery programming.